Good day, guys. Um, I hope you guys are doing well. Okay, today discussing chapter 9, the types of estimators, the point estimation, and also the interval estimation. Okay, let me just do this. Put it here. Yeah. Okay. All right. Now I'm going to talk about the types of the estimators. Then after the point estimation, then followed by the interval estimation. So you will see that this chapter is very easy, interesting, very easy. So, okay, let me just do this. Yeah. Let's start with the first one, the types of the estimators. I think when you guys were doing STTN121, you talked about the parameter, you also talked about statistic. Okay, now just talk about the types of estimators. So if you check here, under the types of estimators, under the population, you know that this one, we call it population mean, population standard deviation, I mean the variance, population variance, and this is population proportion. Now, under this estimators, this one, because under all of this, there are populations, both this one's going to be the sample mean, the sample variance, and the sample proportion. Okay, let's see. Now, let's start. We have the two types of estimators now, or estimation. We have what we call the point estimation, and we have the interval estimation. The point estimation, we are talking about the population parameter that is estimated by a single number, which is calculated from a sample data. This is the point estimation. Now, you will see when we do questions and also when we look at the examples. The interval estimation. The interval estimation is when we are talking about the unknown parameter that is estimated by an interval. And that interval, remember, is formed by the two values. You will see when we talk about the two values. Those values are calculated from the sample data that you will be given, and also the parameter that is contained within the interval. Okay. Let's see. Now let's look at the point estimation. The point estimation, you know that if you are dealing with this thing of a population mean here, they will give you a data set, which is ungrouped data set. And then maybe they will tell you to calculate the point estimate of that population mean. You know that you can substitute your values there on your calculator and you get the mean. Then, okay, so this is the formula that you are going to use. It's either you can use this formula, but now the problem is it's not, it's gonna be a multiple choice. I'm not sure about the format for this year, but multiple choice plus the written questions. So if they gave you a table, and on that table you have to show that the mean, you have to prove that maybe a certain sample mean is equal to a value, maybe a certain value. I think for you to do that, don't just use this formula, substitute everything, then to confirm the answer, if the answer is correct, substitute those values on the calculator using the methods to find the mean there, and then you check if the correct answer, the one that you're gonna get there, is it correct now? But now look at this now. If they say calculate the point estimate of the population mean, we use the sample mean formula. This is the formula that you are going to use to calculate the point estimator of that population mean. Meaning, when they say a point estimator of a population mean of this, the point estimator of this is this one here. It's this X bar. It's X bar. The point estimator is this one here. This is the formula that you are going to use. Then a point estimator of a population variance here of this one, you are going to use this formula for a standard deviation. And even this one for the standard deviation, you can also substitute these values on the calculator using that method where you substitute your values in the calculator and then you get the standard deviation. But remember, if after getting the standard deviation, you need to square the value that you got for your standard deviation. But remember, if it's not a multiple choice, you'll have to show your workings there by using this formula. You have to show by using this so I can get full marks. So meaning a point estimator of a population variance of this is the sample variance. Is the sample variance. Okay, and then now the point estimator of a population proportion, which is the simple, is this one, is the sample proportion, which is x divided by n. You'll see how, I'm going to show you how to see that this is x, this is n. So when they say calculate the point estimator of the population proportion, use this method of a sample proportion. If they say calculate the point estimator for the population variance, use the method for the sample variance. If they say calculate the point estimator for the population mean, use the method for the sample mean. That's what you do. Yeah. So this is the summary. Talked about this one, the estimators. Okay, look at this now. You see, you are given data set. It's an ungrouped data set. They say calculate the point estimator for population mean. Calculate the point estimator for population variance. Calculate the point estimator for population proportion. Okay. Okay. Now for the mean, remember what I said now. You can add these values, all of them. You divide them by 2, 4, 6, 8, 10. Divide them by 10. Let's check. If where is it? You see, you add them, you divide them by 10, then you get the sample mean, then you are done. For the start, that's the variance. This is the formula that you are going to use. This is the formula that you are going to use. Remember, for this one, you can also punch these values on the calculator, and then you get the standard deviation after you square it. You say that value of a standard deviation, open bracket, you close bracket to the power 2, then you get the answer. And then you get this one, for the population variance. And then for the population proportion, the point estimator of a population proportion, since they said that contains more than 2% for a salt, more than 2%. The 2.26 it's more than, 2.36 more than, 2.11 more than, 2.1 more than, because they are more than 2%. Even this one, more than. We count them 1, 2, 3, 4, 5, 6. So it's gonna be 6 divided by 10. You get the sample proportion as 0.6. So yeah, that's what you do. And again, it is very important for you to know the properties of the point estimators. One, the property number 1, it's unbiased. Here, number 2, efficiency. Number 3, consistency. So those are the properties of the point estimators. So it's very important for you guys to know that. And then now, I think talked about that one for the properties of the point estimators, because I'll focus more on the calculations. Now, for the standard deviation here, if now they say calculate the standard error, this is the formula that you are going to use. The standard error of the mean. The standard error of the mean. You're going to use this formula. You will be given a standard deviation. You will be given the random sample or the sample size. If they say calculate the standard error of the proportion, you're going to use this formula, where this sample is the population proportion. You'll be given in terms of a percentage, and then this one will be n, and then you get the standard error of the proportion. So yeah, and also the properties of that point estimator. I think I also talked about this one. Yeah, this one, yeah. Okay. What's the one? I think now we can talk about the interval estimation, because we talked about the point estimation. You saw the formulas that you guys need to know for the point estimation. It's very important for you to know those formulas. For the interval estimation, we will be dealing with the unknown parameter that is estimated by an interval. That interval is formed by 2 values calculated from the sample data and also the parameter that is contained within the interval, which we call that thing, what we call the confidence interval. Interesting one. So under the confidence interval, we have what we call the confidence coefficient, which is 1 minus alpha. You'll see when we do this. gonna show what I'm talking about. Is it? Let's see if we're given a question here. There's something that I want here. Just want a question. And also you need to know the difference between this. Focus more on the calculations. Just want to check something. Is it where we're given the example? Let's look at this one. They say that the confidence interval for the population mean, okay, when the population variance is known or large n, okay, the other one is small n. The confidence interval for the population proportion, okay, with large n. So meaning, if you are dealing with the population variance that is known, or you have large n, I'm going to show you the formulas because they are not the same. Is it just want to see where they are the formulas because they are not the same. Okay, this is the formula. Look at this. This is the formula for the confidence intervals. And also this is the formula for another confidence interval. When you look at these two formulas, they're not the same. We use this one when the population variance is known. When the population variance is known, we use this formula. But when the population variance is unknown, we use this one. And remember, for this one, n will be less than 30. When the population variance is unknown, n will be less than 30. Again, if n is greater or equal to 30 and the population variance is unknown, you use this method. I'll repeat. If the population variance is known, we use this formula. But if the population variance is unknown and n is greater or equal to 30, we use this method again. You'll see when you do the questions. Then this one is for the proportions, the confidence interval for the population proportion. That's the formula that we are going to use. Then this one, it's a confidence interval for the population mean. We have two formulas. But under this one, we have only one formula under this one. So just gonna check. Just want at least one question so I can show you. We talked about this one, this formula. Okay, just want one question. Okay, look at this one. It says the actual content of cold drink in a 500 milliliter bottle is known to vary. Okay. The standard deviation is known to be 5 milliliter. 30 of these 5 were selected at random and their mean content found to be 498.5. Calculate the 95% confidence interval for the mean content. So you'll be given this kind of questions. So they say you must calculate 95%. Let's look at what is the standard deviation there. It's 5. And what is n? They said, what is n? 30 of this. N is 30. The X bar is 498.5. Nay. But let's check. The question is, do we know whether we are dealing with the population standard deviation or not? If you look at this formula, it says that X bar plus or minus Z 1 minus alpha divided by 2 divided by population standard deviation over square root of n. Look at this condition. The condition is that if the population standard deviation is known, use this formula. If the population standard deviation is unknown and n is greater or equal to 30, use this. So the reason why we are using this one is because n, the population standard deviation is unknown and n is greater or equal to 30. That's the reason why we're using this formula. So when you see X bar, you're going to put the 498.5 plus 1 minus alpha. We will be given alpha. Alpha, you're going to use this one. Let's look at this. This is how you do it now. Again, it says that Z, where is it? Z 1 minus alpha divided by 2. So you're just gonna say Z, you're just gonna say 1 minus for the alpha. The method I used to use now, I used to say something like this. I used to say 1 minus 0, I get this 95%, 0.95, and then divide by 2. I used to use this method. on my side. I used to use this one. So it was going to be 1 minus 0.95 divided by 2, which you will get what? Now let's check. 1 minus 0.95 was my calculator. Okay, 1 minus 0.95. And then divided by 2. You will get 0.025, which is this one. But now, since you got 0.025, I come again and be like, okay, 1 minus that 0.02, which will give you 0.975. This will help me to get what we call the critical value, something like a critical value, which is going to be 1.96. But remember, you can also claim this by this way. You'll be like, if the population standard deviation is unknown, if it is unknown and n is greater or equal to 30, and then they want 95% confidence, then 95% is always 1.96, but it depends if the population standard deviation is it known or unknown, and what is the value of n. Because if the population standard deviation is unknown and the value of n is less than 30, you're not going to use 95% confidence as 1.96. No, it will change. You're not going to use that one. Here in this case, population standard deviation is unknown, but n is greater or equal to 30. So you're going to use that formula. And we used 1.96. How do you get 1.96? You go to your table under the area, you check the z value, and then you go to 0.975 here. Under 0.975, it corresponds with what? Now 1.960. And 1.960 is the same as 1.96. You substitute your values, you be like, that 498 of the sample mean plus or minus 1.96, open bracket. Standard deviation, it was 5 over square root of, and it was 30. You're going to get two values. That's the reason why they said the interval is contained within this range, because it's two values. They call this one a lower limit. The other one, they call the upper limit. Like that, yeah. Now, we can now conclude, Gucci, we are 95% sure that the population mean lies in this interval between this one and this one. Yeah. And then what's the other one? This one, okay. Because I think it's the same thing as the previous question that we're doing. Because you just need to check if you are dealing with the population standard deviation that is known or unknown. And we also check the value of n. When you look at this one, n, it was 50 employees, and then the sample mean is 10, the standard deviation is 5. So you can see that on this one, you're still going to use this one, this formula, because the standard deviation is you're gonna use the formula for a sample standard deviation here on this one, because already we have the sample standard deviation as 10, no, as 5, yeah, 5, and then over square root of n. Because if you compare these two formulas, if you compare them, let me show you what I'm talking about. Just want to show you something. It's something that I want to show you. Something that I want to show you. To check if we are given. Okay. You see on this one, they say a zoologist is interested in estimating the mean blood sugar levels of a certain mammal after the animal has received a specific dose of adrenaline. A sample of what? A sample of 55, meaning n is equal to 55, is chosen. Okay, what about the sample mean? The sample mean and the sample standard deviation. The sample mean is 126.9, sample standard deviation is 10.5. Construct 95% confidence interval. Now, if you check on this one, if you check on this, the sample standard deviation is known. Remember the conditions. Let me go up there. I don't know if I'll be able to find them. Um, okay, just want to show you something. Look at this. If n is less than, if n is greater or equal to 30, if it's greater or equal to 30 and the population standard deviation is unknown, it means that you're going to replace this by this. Therefore, you're going to use this formula. You know why? Because n is greater or equal to 30. When you look at this question, just want to show you something, how to see there on the questions. When you look at this question here, n is greater or equal to 30 because it's 55 and 55 is greater than 30. So that's the reason why you're going to use the same formula. Then you know that for 95%, you always use a 91.96. But remember, you need to check if the population standard deviation is known or unknown and check the value of n. Here in this case, n is greater or equal to 30. And population standard deviation is unknown, meaning the sample standard deviation is the one that you know, the known. That's the reason why you are given the sample standard deviation. Use this formula, you substitute your values, and then you get these two values, the intervals. Then yeah, that's how you do it. Start the one. Start the one. Okay, then this one is for a small sample. I think which one? Because I'm just trying to check here. The confident if you guys are going to use these formulas, this formulas. Because I think we on the previous I think we did the questions that are based on what I think we did something like this, the t values. Yeah, I think we did them. The t values. Okay. Let's check something here. Where is it? Yeah. So now, even on this one, if you check the two formulas, 1, 2, the other one is for z, the other one is for t. If you check on this one, the reason why they're interested in this method, we only use this method only if the conditions is that n must be less than 30 and the population standard deviation is unknown. That's when you're going to use this formula. N must be less than 30 and the population standard deviation has to be what? Unknown. And then you're going to use this method. You'll see when we do the questions. Where's the example? Look at this example here. You see on this example, we are given what? We are given the data set. The data set, it says that the time in seconds taken to complete a task was recorded for each of 15 randomly. So n is equal to 15. So can you see that n in this case is equal to 15? So because now it's less than 30 now. So what do we do if n is less than 30? If n is less than 30. If n is less than 30, then we less than 30 and the population standard deviation is unknown, meaning now we're going to talk about the sample standard deviation. You're going to use the method of you want to punch the values on the calculator, you get the mean, you get also the sample standard deviation on this one here. You see this, so what we do it, you're going to punch this, you get the mean, you also get the standard deviation. N already is equal to 15 because you see it's there. Then they want you to do what? To calculate the 90, 95 and 90% confidence. For 95%, we know that it's 1.96. Then 90%, it's 99%, it's 2.58. And then for 95%, it's 1.96. 99, it's 2.58. And then 90% is 1.645. But here, because n is less than 30, and the population standard deviation is unknown, we have to find the degrees of freedom by saying degrees of freedom is equal to n minus 1. And also to find the standard deviation and also to find the mean, sample mean. So that's how we do it. So see, Let me show you something. This one of Tn minus 1 is the one for degrees of freedom. Tn minus 1, n minus 1. 1 minus alpha divided by 2. So if they said 95%, ne, you can also use this method here. Or you can say 1 minus 0.95 divided by 2, which you will get 0.025 here. And then you say that 1 minus 0.025, you will get 0.975. Or you can do it this way. You say 1 minus the alpha and 200% is equal to 95%. And then what you do, you divide both sides by the other percentage, by the 100. So 95% divided by 100%, you will get 0.95. Then you solve for alpha, you get 0.05. Then you divide it by 2, which is 0.025. But Mina, I used to use this method of 1 minus 0.95 divided by 2. Divided by 2. 0.95 divided by 2. The answer that I'm going to get is going to be 0.025. Then after, I'm going to say 1 minus that 0.025. And then I'll get 0.975. It will help you. Now, after, if n, it was 15, the degrees of freedom will be 15 minus 1. And it's going to be 14. You're going to check 14, and then you check 0.975 there. Then you get your critical value there. You substitute already, you have the mean and you have the standard deviation. You substitute your mean value, the critical value, and the standard deviation value and the value of n. You're going to get the two values here. That's the reason why it falls under the interval estimation. So you see the difference now. You just need to check if n is less than 30, n is greater than 30, and if population standard deviation is known or unknown. You need to check that. And there, what's the other one? There's this one. This one, is it? The one for the proportions. You see, they will give you this kind of questions. I want the one for the proportions. Proportions. This one is easy because if they say for 90%, you use the critical value as 1.96. No, 1.645. And then for 95, you will use 1.96. And then for 99%, you use 2.58. This is the formula you're going to use. P cap, which is the sample proportion, plus the z1 minus alpha divided by 2 into square root of the standard error. This one. Let's look at the question. This is the method we're going to use. Remember, for those two answers, there will be an answer where on your calculator you're going to have the subtraction. Then there will be another answer you're going to have the positive where you're going to add. Yeah, two answers. So let's look at the question. Look at this. During a marketing campaign for a new product, 176 out of 200. So meaning the potential here is 200. It's 200. And then out of that 200, they found out 175 of them here, out of the potential users of this product were contacted, indicated. So meaning X will be 176, then N will be 200. That's what they did here. 176 divided by 200. You get 0.88. But then now when you check 0.88 as the P cap. Now to get, they said what? Calculate the 90% confidence. Okay, remember I said with this one, with the population proportions, the confidence interval for the population proportions. Then 5%, 90% for this one is going to be 1.645. How did they get 1.645? You're going to say 1 minus 0.9, 0.9, and then divide by 2. Divide by 2. Divide by 2. You get the answer. That answer that you get, you minus with you say 1 minus that answer. You will get 0.95. You're going to go here under the Z, you want to check where there is 0,950. You'll see that it corresponds with 1,645. Okay, that's what I did here. Here. So I did here. 1,645 for 90%. You substitute your values there. You see, what is the P cap? 0,88 plus 1,645, or the minus multiplied by the standard error of the proportion. And then you get the answer. You get the answer there. So you need to check. If you are given a question, check if you are given the mean, check if you are given n, check if you are given the standard deviation. If you're not given, just know that it falls under the confidence intervals for population proportion. Just this one here. This one. I think, yeah. Yeah, that's the end. That's the end. And then what is the other one? I think I'll have to do three parts. This one will be part one. Other one will be part two. Part three, I'll be doing the question papers. Yeah. And guys, please don't forget to like and subscribe to my YouTube channel so that you can see more videos about it for STTN121. When I upload my videos, you can see the notification for STTN121. So that you can pass the module. You can see that now this module is not difficult, interesting. You just need to understand the basics and apply them in the test or the exam. So yeah. So this one will be part one.